Good day everyone, we are Group 6 and we will be discussing Chapter 7 about soil. Aside from the water we drink and the air we breathe, soil is also one of the important natural resources. We need to protect soil by keeping it healthy and using it wisely. The healthier the soil, the healthier the products that come from it. We all need healthy food to eat, but our soil does more than just feed us. It is a big part of our economy. So, bakit mahalaga sa atin ang lupa o soil? Mahalaga ang lupa dahil dito tayo nagtatanim ng mga plants na ating kinakain. Dito rin tayo nagtatayo ng mga bahay at mga gusali. Nakakatulong din ang lupa para maiwasan ang pagbaha sa bagyo sa pamamagitan ng pagsipsip ng tubig. The soil profile. The soil profile is defined as a vertical section of the soil from the ground surface downwards to where the soil meets the underlying rock. Virtually, all soil profiles are composed of a number of distinctive layers termed horizons, interpretation of which is the key to understanding how the soil has formed. So basically, ang soil profile is yung pagkakaiba o yung layer na tinatawag na mga horizon. So ano-ano yung horizon? So meron O horizon, A horizon, B horizon, C at R horizon. So mag-start tayo sa A horizon. Ang A horizon ay nahati sa dalawang part, which is yung organic and the surface or yung topsoil. Ang organic horizon, yung pinakataas na part ng soil, and ito ay gawa sa mga tuyong dahon at mga patay na halaman at insekto. Sa A horizon naman, dito nabubuo ang humus na nanggagaling sa mga tira-tirang parte ng mga dahon, halaman at insekto na nanggaling sa organic horizon. Ang B horizon o subsoil ay yung gitna na layer ng soil. Ito ay mas matigas at mas light ang kulay dahil konti lang ang humus kaysa sa topsoil. Next is yung C horizon o substratum. Dito, wala or napakakonti lang ng humus. Ang substratum ay may mga maliliit na bato na nanggaling sa bedrock. So, last is yung R horizon or yung bedrock. Ang bedrock ay ang pinakailalim at pinakamatigas na layer ng soil. Ito ay may iba't ibang uri ng bato kagaya ng granite, basalt at limestone.
12 orders of soil taxonomy. Number 1 is the alphisols. The word alp refers to aluminum and iron. It is usually formed in subarid and humid areas. It is a high native fertility. So, ang alphisols is nagko-contain yung soil niya ng aluminum and iron, which is responsible sa pag-remove ng toxic and nutrient deficiency. Ang alphisols is usually nagpo-form siya sa mga forest at matataas na lugar. Next is andisols. Andisols is also known as andosols. Ando means black soil in Japanese. Andisols is a soil that form in volcanic ash or other volcanic ejecta. Ejecta, it is caused by explosive eruption. Next is aridisols. Aridisol is from the Latin aridus, which means dry. It is a form in an arid or semi-arid climates, meaning ang aridisols is a soil na napoform siya sa desert climate, which is yung mainit at tuyot. Kaya nga siguro siya tinawag na desert soil. Next is entisols. Entisols is a soil of recent origin. It is found in steep and rocky setting. It has no diagnostic horizon. So, ang entisols is makikita o matatagpuan siya sa matatarik at mababatong lugar. It has no diagnostic horizon, meaning hindi siya nagpapakita ng any profile development other than an A horizon. Pero kahit hindi siya nagpapakita ng profile horizon or profile development, nagbibigay pa rin ito o nakakapagbigay pa rin ito ng sapat na supply ng nutrient or sustansya sa tubig at halaman. Usually, ang feature ng isang empty soil is parang walang buhay or parang patay na lupa na. Next is jelly soils. Jelly soils is from the Latin gelare, which means to freeze. Jelly soils are soil of very cold climates that contain permafrost within 2 meters of the surface. So, ang jelly soils is, ito naman yung soil na napo-form sa mga malalamig na lugar. It does contain permafrost within 2 meters of the surface. Ang permafrost is a ground that remains completely frozen up to 32 degree Fahrenheit. Ganon siya kalamig. And usually, ang mga jelly soils na mga soil is located siya sa mga Alaska, Canada, ice-free part of Greenland, and Antarctica. And then next is histosols. Histosols from the Greek word histus, which means tissue. The soil are formed in decaying organic matter. So, histosols are formed under waterlogged conditions, typically of peat bogs, moors, and swamps. Under such conditions, the accumulated tissue of dead plants and animals and their decomposition products are preserved, resulting in soil of high organic content. So, yung histosols, in other word, is napo-form siya from mga nabubulog na mga tissue ng plants and animals at yung mga naiipong tubig sa mga mababang lugar. Okay? Next is inceptisols. Inceptisols is from the Latin word inceptu, which means beginning. Inceptisols, it exhibit minimal horizon development. They occur in cool to very warm climate. So, ang inceptisols and entisols is parehas lang sila. The only difference between the two is si entisols is, sabi ko nga kanina, hindi siya nagpapakita ng profile development or any profile horizon. Unlike sa inceptisols, kahit konti is nagpapakita siya ng horizon development. Mollisols is from the Latin word mollis, which means soft. It is a soil of grassland ecosystem that considered as the most fertile soil on earth and a breadbasket soil. Generally, very fertile for plant growth siya due to its clay and organic matter content. The mollisols soil profile showing a typically dark surface horizon rich in humus. The mollisols formed by the accumulation of calcium-rich organic matter. So, in other words, napo-form siya sa dense root system sa patag na lugar or damuhan.
Oxysols. Oxysols is a highly weathered soil and may laman ito na weatherable minerals kagaya ng iron at aluminum. Spodosols. Ang spodosols ay acidic soil with thick E horizon. Yung subsoil has accumulation of iron and aluminum oxide, humus, and amorphous clay. Ultisols. Ang ultisols is a more weathered kesa sa alpisol and have a low base saturation and more acid than alpisol. Vertisols. Sa vertisols, ang physical appearance ng lupa ay nagbabago kapag ito ay tuyo at basa. Kapag ang vertisols ay tuyo, ito ay lumiliit at nagkakaroon ng mga crack. Ito naman ay lumalaki o nag-e-expand kapag ito ay nababasa.
Geological processes. Geological processes are the processes at work in the earth's surfaces and land formations. The dynamics include erosion, weathering, and plate tectonics. And also, geological processes has many kinds, such as volcanic eruptions, volcanism, earthquakes, rock cycle, and etc. Ito yung process whereby geological features are modified. And also, geological processes is a science that deals with the history of the earth as recorded in rocks. Let's proceed to the dynamics of geological processes. The first one is erosion. Erosion refers to the wearing away of the field's topsoil by the natural physical forces of water and winds. And also, erosion is the action on Earth's surface processes such as water flow or winds that remove soil, rock, or dissolved materials from one location on the Earth's crust and then transport it to another location. Erosion involves three distinct actions. The first one is soil detachment, second is movement or transportation, and the third one is deposition. Soil detachment is defined as the dislodgement of soil particles from the soil mass at a particular location on the surface. Movement or transportation is a movement of soil and regolith that more resembles fluid behavior, also called flow. Deposition, a process in which sediments, soil, and rocks are added to a land form or land masses. Weathering. Weathering is the breakdown or dissolving of rocks and minerals on Earth's surface. No rock on Earth is hard enough to resist the forces of weathering and erosion. So, ibig sabihin, any rock and land formations can be affected by weathering and erosion, and it may cause some deformations of that form. Weathering is often divided into the processes of biological weathering, chemical weathering, and mechanical weathering. So let's start with biological weathering. Biological weathering is weathering caused by plants and animals. When plants and animals release acid-forming chemicals that cause weathering and also contribute to the breaking down of rocks and land formations. Chemical weathering is weathering caused by rainwater reacting with the minerals grain in rock to form new minerals, clay, and soluble salts. This reaction occurs particularly when the water is slightly acidic. Chemical weathering such as acid rain eats away at certain types of rocks such as limestone, creating cracks and holes. While mechanical weathering or physical weathering breaks rock into smaller pieces, the rock has changed physically without changing its composition. The smaller pieces have the same minerals in just the same proportion as the original rock. And also, it is a weathering caused by breaking down of rocks by physical forces without any change in the chemical nature of rocks. It is usually caused by extreme hot and cold temperatures. Water seeps into cracks in rocks, freezing and expand causing further breakdowns of rocks. So, dito sa mechanical weathering, temperature really affects the composition of rocks. There are different types of chemical weathering. The most important are solution, hydrolysis, and oxidation. The first one is solution. Solution is the removal of rock in solution by acidic rainfall. And hydrolysis is the breakdown of rock by acidic water to produce clay and soluble salts. While oxidation is the breakdown of rock by oxygen and water, often giving iron-rich rock and rusty-colored weathered surface. Chemical weathering is weathering caused by rainwater reacting with the minerals grain in rock to form new minerals, clay, and soluble salts. This reaction occurs particularly when the water is slightly acidic. Chemical weathering such as acid rain eats away at certain types of rocks such as limestone, creating cracks and holes. While mechanical weathering or physical weathering breaks rock into smaller pieces, the rock has changed physically without changing its composition. The smaller pieces have the same minerals in just the same proportion as the original rock. And also, it is a weathering caused by breaking down of rocks by physical forces without any change in the chemical nature of rocks. It is usually caused by extreme hot and cold temperatures. Water seeps into cracks in rocks, freezing, and expand, causing further breakdowns of rocks. So, dito sa mechanical weathering, temperature really affects the composition of rocks. There are different types of chemical weathering. The most important are solution, hydrolysis, and oxidation. The first one is solution. Solution is the removal of rock in solution by acidic rainfall. And hydrolysis is the breakdown of rock by acidic water to produce clay and soluble salts. While oxidation is the breakdown of rock by oxygen and water, often giving iron-rich rock and rusty-colored weathered surface. So let's proceed to the third dynamic of geological processes, which is the plate tectonics. Plate tectonics is derived from the Latin word tectonicus, means pertaining to building. Plate tectonic is a scientific theory describing the large-scale motion of 7 large plates and the movements of large number of smaller plates on Earth's lithosphere. Yes, it is a theory where Earth's outer shell is divided into several plates, where these plates used to glide over the mantle, which is the rocky inner layer above the core. Lithosphere is a solid part of the Earth in rock. Based on the theory, because of the sudden movement of the Earth crust, may nabubuong major plates, which is the Eurasian, African, Australian, Indian, North and South American, and Arctic, which we are used to call the 7 continental plates. And parang dahil na din sa paggalaw ng mga plates ay nagtitrigger ito ng movement sa kalupaan and will cause some geological features and hazard.
Formation. Soil and soil formation can be considered from many standpoints, including from the study of soil science as a field in its own right. However, soil is most important in ecological function as the basis for the growth of terrestrial plants, including supplying nutrients, water, temperature moderation, and support. The process by which soil is formed as a result of interaction over time between parent rock, climate, topography, and organisms is called pedogenesis. Pedogenesis is the process of soil formation as regulated by the effects of place, environment, and history. Biogeochemical process acts to both create and destroy order within soils. It is a term for soil formation that describes the combination effect of biological, physical, chemical, and anthropogenic process on soil parent material. Factors of soil formation. Parent material. It is a soil mineral forming the basis of soil. They are usually products of rocks through the process of weathering and natural erosion. Water, wind, temperature change, gravity, chemical interaction, living organism, and pressure difference all contributed to break down the parent material. The types of parent material and the condition underlying which they break down will influence the properties of the soil form. For example, soil formed from granite are often sandy and infertile, whereas basalt under moist condition break down to form fertile clay soils. Soil parent material can be grouped into 3 classes, namely residual sedentary, transported, and cumulus. Residual or sedentary develop in place from underlying rock. This can be found underlying any rock type. The landscape should be stable enough for a good amount of time for weathering to occur. Transported. It is a loose sediments or surficial material. Weathering products of rocks that are not cemented or consolidated, that have been transported and deposited by gravity, water, ice, or wind. These materials are classified on the basis of the agents responsible for their movement and deposition. Cumulus. It is an organic deposit that have developed in place from plant residues and have been preserved by a high water table or some factors of decomposition. These deposits are widespread and not restricted at any climate zone. Examples include peat. It is an undecomposed or slightly decomposed organic material or matter, and mud, a highly decomposed organic matter. Climate plays an important role in the genesis of a soil. The two most important climatic variables influencing soil formation are temperature and moisture. Temperature has a direct influence on the weathering of bedrock and produce mineral particles. Rates of bedrock weathering generally increase with higher temperature. Temperature also influences the activity of soil microorganisms. The frequency and magnitude of soil chemical reactions and the rate of plant growth. Moisture levels in the most soil are primarily controlled by the addition of water via precipitation minus the losses due to evapotranspiration. Temperature affects the rate of withering and organic decomposition with colder and drier climate. This process can be slowed down, but with the heat and moisture, they are relatively rapid. Rainfall dissolves some of the soil materials and hold others in suspension. The water carries or leaches these materials down through the soil. Over time, this process can change the soil, making it less fertile. If additions of water from precipitation surpasses losses from evapotranspiration, moisture levels in a soil tend to be high. If the water loss due to evapotranspiration exceeds input from precipitation, moisture levels in a soil tend to be low. High moisture available in soil promotes weathering of bedrock and sediments, chemical reaction and plant growth. The availability of moisture also has the influence of soil and the decomposition of organic matter. Living organisms. Living organisms has a role in a number of processes involved in pathogenesis, including organic material accommodation or accumulation, profile mixing, and biogeochemical nutrient cycling. The equilibrium condition, vegetation, and soil are closely linked with each other through nutrient cycling. The cycling of nutrient and carbon in soil is almost completely controlled by the presence of animal and plants. Cell formation is influenced by organisms such as plants, microorganisms such as bacteria or fungi, burrowing insects, animals, and humans. As soil forms, plants begin to grow in it. The plant matures, dies, and new one takes their place. Their leaves and roots are added to the soil. Animal eats plants and their waste, and eventually their bodies are added to the soil. This begins to change the soil. Bacteria, fungi, worms, and other burrow break down plants litter and animal waste and remains to eventually become organic matter. This may take the form of peat, humus, and charcoal. Through later fall and the process of decomposition, organisms add humus and nutrients to the soil, which influences soil structure and fertility. Surface vegetation also protects the upper layers of the soil from erosion by way of binding the soil surface and reducing the speed of moving wind and water across the ground surface. Topography generally modifies the development of soil on a local or regional scales. Soils developing on moderate to gentle slopes are often better drained compared to the soils found at the bottom of the valleys. Good drainage enhances a number of pedogenic processes of elevation and alluviation that are responsible for the development of soil horizons. The shape, length, and grade of a slope affects drainage. The aspect of a slope determines the type of vegetation and indicates the amount of rainfall received. These factors change the way soils form. Soil material are aggressively moved within the natural landscape by the action of water, gravity, and wind. For example, heavy rains erode soils from the hills to lower areas, forming deep soils. The soils left on steep hills are usually shallower. Transported soils including alluvia or the water transported, colluvial, gravity transported, aeolian or the wind transported. Under condition of poor drainage, soils tend to be immature. Steep topographic gradients inhabit the development of soil because of erosion. Erosion can be retarded the development through the continued removal of surface sediment. Soil microclimate is also influenced by topography. In the northern hemisphere, south-facing slopes tend to be warmer and drier than north-facing slopes. This difference results in the soils of the two areas being different in terms of depth, texture, biological activity, and soil profile development. Time. Time influences the temporal consequences of all factors described above. Soil properties may vary depending on how long the soil have been weathered. Minerals from rock are further weathered to form minerals such as clays and oxides of iron and aluminum. Pedogenic processes in young soils are usually under active modification through negative and positive feedback mechanisms in attempt to achieve equilibrium.
What is soil conservation? It is the prevention of loss of the topmost layer of the soil from erosion or prevention of reduced fertility caused by overusage, acidification, salinization, or other chemical contamination. Soil conservation practices are tools the farmers can use to prevent soil degradation and build organic matter. These practices include crop rotation, reduced tillage, mulching, cover cropping, and cross-slope farming. Farmers to increase soil organic matter content, soil structure, and rooting depth.